Okay, quadratics and inequalities. We're doing two things here, kind of combining it. So here's these two formulas up here. I said forms, but you have the vertex form. Our vertex form, you can see there's an A, which we'll talk about the A in a little while. X minus H, what's the H represent? X coordinate of a vertex, the K is our Y coordinate. So we're going to be using our vertex form. You know, A is just your stretch or your compression. All right, and then we have your ax squared plus bx plus c form, which you dealt with a lot. Okay, so we're going to kind of work with that to find the vertex as well. You guys remember this in the past? It's negative b over 2a. Okay, that's how the x coordinate of the vertex. And then once you get that number, you plug it into the equation to figure out the y coordinate of your vertex. All right, so all that being said, first thing I want to make sure we have it. If a parabola opens upward when the a value is what? Positive. Okay. Okay, a parabola opens downward, so I'll just write it down. Down when our value is negative, right? Less than 0. Now, if we have a parabola, we have this vertex, we talked about this in this class already. It could also be, the vertex can also be called a what? Maximum or minimum, right? So when I say max or min, okay, I didn't penalize you guys this, but if I say max, I want the y value, the y coordinate. If I want the minimum value, I want the y coordinate, okay, not the point. Because the x value just tells you when it happens or where it happens. All right? Everybody good with that? Okay, so what I want to do, really to be honest, example 1 is going to cover the majority of what we're doing today. I'm going to kind of cover all in one big grouping. I'm going to let you kind of work a lot of these. All right, any questions before we do this one? Yes, sir.
Can you give
Another one? Here we go. All right, so this one. Let's go ahead and just do this. Because you don't like the way it's written. Just rewrite it. Negative x squared plus 2x plus 8. You like that? Form better the order, correct? Which way does this open up? Open up, down. It's down. Why?
Negative.
Yeah. The number in front of our x squared is negative. Okay, so that's our a value. So it's opening down. Okay, vertex. This goes back to what we were talking about earlier. Remember, you have the x coordinate and the y coordinate. So our x coordinate of our vertex is negative b over 2a. So what's the b value? 2, right? The number in front of x. So hold on. So negative b, so negative 2. Right? Negative b, so negative 2 over 2 times what? Negative 1. So if we did all that, what would we get? 1. So the x coordinate of our vertex is 1. How do we determine the y coordinate? Plug it in. So f of 1, let's write it right here. We take 1, we plug it back into our function, original function, and we get 9. So our vertex is 1, 9. Good so far? So basically what we're doing here, everything we're trying to solve this is without a calculator. Okay, x-intercepts. That's when you set it, what equals 0? The y. So we're going to take negative x squared, right over here. Negative x squared plus 2x plus 8. And we're going to figure out when does that equal to 0. This is solving quadratics. The first way you typically do is try to factor, right? Now you don't like the negative in front, so we could just take everything and divide it by negative 1. It's like factoring out a negative and dividing that negative across. So you have x squared minus 2x minus 8, and we still have it equal to 0. How's that factor? X minus 4 and x plus 2. Obviously, we can set both those equal to 0. We figure out that our two x-intercepts are what? Negative 2, 0, and 4, 0. How are we doing so far? Okay. Like I said, we're going to grab everything here at once. A lot of things have been thrown at you. So we have all that stuff taken care of. Now it's the y-intercept. How do you figure out the y-intercept? Plug in 0 for x. So let's put it over here to the side. This would be f of 0 for our y-intercept, just f of 0. So that's equal to 8. So 0, comma 8. Right? 0 squared plus 2 times 0 plus 8. Any questions up to that point? All right, axis of symmetry. After if you drew that line, it would be symmetric, right? It'd be equal on both sides. So the axis of symmetry is what? Okay, it's always a vertical line. And it's the x-coordinate of our vertex. So it's x equals 1. You know where the middle of that parabola is. It's on the vertex. That's the x-coordinate of your vertex. All right, domain. I haven't graphed it yet, but I bet we can still answer this. Is there anything restricting our domain? So it's all real numbers. Negative infinity to infinity. Okay, range. Negative infinity to 9? Inclusive? Because 9 is a what? Max, right? 9 is a max. So we're going from everything from below all to the top. All right, so increasing, again, we have not graphed it, but I want to see if you can figure this out. Where's our function increasing? Negative infinity to 1, right? And where's it decreasing? 1 to infinity. It's because, I'll go over here to the side, we know we have something that looks like that, right? A maximum. Yes, sir?
So why would I not put bracket after 1? Say it's including that one.
Hold on a second. Ask me again.
Why would I not put a bracket there when I say it's including?
Okay. Increasing, decreasing. Increasing, decreasing. Everybody can see your eyes real quick. I want you to hear it. I've said it before, but I want you to hear it again. If we're talking about increasing, decreasing, just use parentheses. Only use parentheses. Don't use brackets. Everybody hear me? If we're talking about increasing or decreasing, only use what? Parentheses. So when's the time for brackets? Well, domain and range. That might happen there. I'm sure some other cases I can't think off the top of my head, but we're talking about increasing, decreasing, always use parentheses.
So like, why would I not?
Let me get into that later, as far as what the definition of increasing and decreasing is. All right? Now, vertex form. Try vertex form. It's up here. Remember, that's the a, x minus h squared plus k. So I'm going to write it as f of x equals, well, what's our a value? Negative 1. So negative, parentheses, x. We know our vertex, so it's x minus 1 squared. And then we know our k value, the 9, right? Plus 9. So just to reiterate it. This is h and k, right? The 1 and the 9. So it goes into our vertex formula from up the top. Everybody see how we got this line right here? Okay, so I'm going to come back to limits really fast. Let's graph this because we have points and stuff all over the place. So we have 0, 8, 1, 9. What else do we have? Some x-intercepts. Negative 2, 0, and 4, 0. What other point do you think is there for sure?
3, 5.
2, 8, I would say is on there. Right, because you can see it's symmetric. And then from here, let's just go ahead and I'm good enough for me to plot our parabola. So last thing. And then I was going to answer your question she asked me. Okay. The limit as x approaches 3 of our function f of x. So as x approaches 3, from the left and from the right, you see how there's definitely a value assigned right here? And I can't go by eyeballing, I must drew that by hand. How do we figure out what that spot is? Plug 3 into the equation. Everybody hear that? To evaluate a limit, unless there's something weird going on, like some type of weird division, which is nothing, it's just a polynomial, nice polynomial, just plug it in. Okay, so if you plug in 3 for the x's, do all that work, we're going to get 5. So limit as x approaches 3 is 5. It looks like us somewhat close over there. All right? What if we said the limit as x approaches negative 1? It's also going to give us 5. All right. I know. So we get all those values. We good with those. Just plug them in. Just plug them in. All right? As x approaches negative infinity, what's What's negative infinity? That's the y value we're getting closer and closer to. What about positive infinity? Negative infinity. Okay, so I'll address the increasing, decreasing question. Is there anything else that you guys have over any of this? Okay, example 2. I want you guys to do that on your own. Okay. All right. Hey, example 2, do that on your own. Make sure, obviously, we check that one with this on canvas. Example 3. Okay, we have to write an equation. It says an equation. It says what form or anything like that. Just has to make an equation involving these 2 points. But one of these points is really important. Like it helps us a whole lot. Which one is it? The vertex. This instantly makes us think that we should probably use vertex form with this one. All right, so just one more quick. So f of x, reminder, it's a, whatever that is, x minus h squared plus the k. Now, what's the 4? Which variable? That's your h. And then there's our k with a negative 1, right? Here's just some point thrown out there, which we can substitute in for what? X and f of x, right? Because it gave us a point on that parabola as well. So let's go through here. F of x is now 3. A, we don't know the amplitude. We don't know how we're moving this thing as far as stretching it or compressing it, so we're going to leave it. X is 2. Minus our h value, 4. And then we're going to add that negative 1, so just minus 1 is fine. Okay, so really the only thing we're not sure of on our formula is the a value, right? So 2 minus 4 is negative 2. Negative 2 squared would be 4, so we're left with 3 equals 4 times a minus 1. So a is equal to 1. All right, add the 1, divide by 4. So basically what we have here, this says now to write an equation, we would say f of x equals 1, right? Which we don't have to write the 1, but I'm going to right now just because it's not always going to be a 1, obviously. And it would be x, what is it? Minus 4 squared minus 1. So there's our right an equation. All right? So I want any questions? Yes, sir.
Does the squiggly 1 represent anything?
It's hard to tell. That's a negative.
Oh, that's like
It's a negative. That's why our k value was minus 1.
Oh, I see what you said. Oh,
All right, so example 4. Let me give you, it won't take very long. I want you to try to write an equation for example 4. All right, we'll check it here pretty quick. All right, so hey, raise your hand if you have one. Go ahead.
F of x equals x squared minus 12x plus 32
Run that again. So you said x squared
minus 12x plus 32.
plus 32. Does that produce these points on that? Is that a quadratic that has these 2 points? Yes. Josh, go ahead.
parentheses, x minus 4, and then parentheses, x minus 8.
X minus 4 times x minus 8. But if you took this and expanded it out, multiply it through, would it equal that?
Yes.
Yes. So they're the same thing. Go ahead.
What's preventing it from being added or
Multiply? Like, what if I did something like this real quick? I'm not sure what you're asking, but,
Like how do you know there's no other coefficients?
okay. So watch right here. I know what your question is, and I'll introduce it. Before I forget this though, what if I did this? Is that okay? Yes. Does this 9 have, does that change the fact that this quadratic has these 2 points? So, like a rock wrestling, we had like an a value here. A could be anything except 0, because then it would no longer be a quadratic. So we can't have another, I think this kind of answers your question, we can't have another like something else out here, because that would then imply that it's something besides a quadratic, and everything here is quadratics. So I couldn't throw like an x right there. So then it would be a cubic. All right? So before I give you the last one, just to kind of get us moving forward on this, example 5, which you've done before, we've done this class probably in a much more difficult setting with parametrics and stuff, but a ball's thrown by a child, here's the model equation for that situation. X represents how far horizontally it's moving. Let's make you think of parametrics a little bit. All right? We're saying how high is the ball when it reaches its maximum height. Okay, so what's the maximum height attained by the ball? All right, now, first thing we need to figure out is when horizontally it happened, correct? How do we figure that out? Vertex. So x equals negative b over what? 2a. So we're just finding the x coordinate of our vertex. So what is that going to be? Negative 1 over 2 times what? Negative 1/8. Oh, so that would come out to be 4 when it's all said and done?
Yeah.
So 4 is our x coordinate of our vertex. But we want to know what's the maximum height. The maximum height. That would be the y coordinate, right? So take that 4 and do what with it? Plug it in. So we would take that 4, and everywhere there's an x, we're going to substitute the 4 in place. Now I'll put parentheses around this just because you know that I substituted. We got 6.
Yeah.
6 feet. So it's just asking what's the height of the ball. It's not saying how displacement or like, the girl threw it, right? Or the boy threw it, or the child didn't say which one, and it comes up. We don't know how far up that went. Like, here's my question. When the child released, what height did they release the ball, you think? 4. Where'd you get that from? Like, if you remember how we, instead of X's last semester, we used T's like for time? So, if 4 feet was where the ball was released, and then however they threw it, it went up to 6 feet was the maximum height what they did at that particular time. See, so I can ask different questions. That's what I'm trying to get across to you with this situation. Y'all have all seen it before. All right, so here's the thing. Example 6. Example 6. I'm going to give you some time on that one. It is everything up to this point, I hope, has felt pretty smooth. There's stuff we've run into. Example 6 is going to kind of push you a little bit. And it puts you into like a real world type situation. See if you can handle that one. All right, so let me step back, and you and your partner look at example 6. All right, so part A, you have this situation with calculators and have all these variables that are assigned. Okay, what does the P represent? That's how much we're charging for the calculator, right? X represents how many we sold. Now, it says write a model for the revenue function. So R in part A. R of, well, it says as a function of the price P. So it's R of P, right? R of P. Now, there's a difference between, just for business aspects, between revenue and profit. Okay, profit is how much money we made, right? We sold some stuff. We had to spend money to make that product. There are costs, right? You subtract those, you get your profit. Revenue is just how much money was brought in. We sold some stuff. How much money did we bring in? It's not how much money we made. It's the difference between revenue and profit. You know, follow me on that? So if we're talking about how much money was brought in, there's only 2 things that matter with that, with this situation. What are those 2 things? The price of the calculator and how many you sold. So the price we know is P. So that's involved. And we're going to make money, that much money, in fact, every time we sell a calculator, correct? So that would be multiplication. So P times X. The price of the calculator times how many calculators we sold. Now, we can't leave it like this because it has to be R of P, and we have a variable X in there. How do we get rid of the X? So we need to take that X, and it's equal to 21,000 minus 150p. Now, you have a function here. What kind of function? Quadratic. If you distribute your p, you'll see that quickly. And that's what we're going to use to answer all these questions following. Any questions on how we got that? Go ahead.
So what is the X thing then? What is that X equation?
So X represents the number of calculators sold given by this demand equation. So we're going to analyze this demand equation here in a little bit. But this is X represents the number of calculators sold. Now what's going on here? I want to see if we can kind of figure that out before we talk about it. All right, so keep on going. Answer the remainder of those, please. All right, so take a look, make sure you're good. Here's the thing, you will see this again. You will see it again, a problem like this.
On the test?
Yeah.
What?
So you will see this again. Now,
For a bug.
don't worry about this cube x. We did this one together. This is the equation you got. Now, the answer is not, I had to mark this out, it's an old key. I had to replace this one. It's not, okay, 0. 0 is the lowest we could charge, right? You can just give the calculators away. The highest it can go is 140. Because I'm going to use this graph down here real quick. Here's a rough sketch of the graph. Once it passes 140, that's an x-intercept, isn't it? And then what's the parabola going to do? It's going to go down to negatives. You can't have a negative revenue. Now think about this from your situation. Think about it from a real world situation here. We can charge $0 for the calculator, which means we make nothing, we just give them all away. Or we can go and charge $140. If we charged $140 for the calculator, based on the marketing department who came up with this data and researched it, how much money would we make up with the $140 if we charged that much? Zero. No one would buy it.
I don't understand that you can make $0 like just giving away your calculators because you have to like get.
Revenue. Remember, not profit, revenue. If we just take our calculator and give away, we're bringing no revenue in. If you charge $140, when someone's going to go, that's too much, I ain't buying that.
No one's gonna buy your calculators at 140.
Right. Okay, based on their data. Yes, sir.
Bad data.
Okay, so if you charge nothing for a calculator, you start giving them out, wouldn't calculators become like relatively worthless?
Yes, this is a theoretical scenario.
If you're manufacturing them, giving them out to people.
If it's free, then it's
All right.
I mean,
Hey, part C. Part C. Negative b over 2a, right? Now, I will say this, because someone they were talking to me about this last block, I want you guys to hear it too. If you had your graph, and you know it's going through 0, 0, which we do, and you can look at the equation, you can tell it goes through 0, 0, then technically speaking, you could just say, well, it's symmetric, right? So it has to be halfway there, 70. If you didn't see that, or if the graph doesn't go through the origin, right, like we talked about earlier, the child throwing from 8 feet or 6 feet, or whatever it was, 4 feet up in the air, then you have to go negative b over 2a to figure out the vertex position. How'd you get to 735? Because I walked around, I saw that. Plug the 70 in. All right, 10,500. Well, first of all, yes. You could take those and just divide, or you could take that price you're charging, the 70, and go and plug it into this equation, right? Because it said, how many units you sold at this price? So plug in 70 for the P, 21,000 minus 150 times 70. Because X represents the number of calculators sold, and this is the demand equation. The demand is dictated upon the price that we're charging. Right now, this one, we want to be greater than or equal to 675. So just look up here for a moment, make sure your eyes are here. Here's your graph. If I were to draw a horizontal line, it would kind of go through this graph, right? It would go through that graph and leave us with the portion above it. A horizontal line at 675,000, because the highest it reaches is 735. Everything above that line, which I'm about to go over in here a little bit, everything above that line is greater than 675,000. So that occurs between 50 and 90. Okay, you guys probably moved it over, factored it out, which was kind of a painful factoring, but you got there eventually. And you got your 50 and your 90. I'm going to show you a more algebraic way of like solving that besides just looking at a graph. Just give me a moment on that. Question? It's not too bad. Okay.
And then you can just like plug in like the negative or like the 4,500 in your calculator, like 4,500.
There you go. That'll work. All right, hey, last thing on this one. Last thing. How many calculators do they have available to sell? 21,000. Let's think about this. We have 21,000 calculators. And how much we have left is dictated by how much we're selling them for. Right now, or how much we sold, rather, excuse me. If I plugged in 0 right there, well, they're all going to be gone. Right? So, we can't just sit here and say, hey, we're going to charge $139 for the calculator. We're not going to sell very many, are we? We have to figure out that middle ground, the optimum spot where we sell it for this much, and that's going to maximize our profit. And we're going to still have some left, but we still make more money in the long run. With revenue, I said profit, I meant revenue. Maximize our revenue. Profit's a whole other thing. We're not going there right now. Okay? So, here's what I want to do with you guys. We are not going to do this entire thing. It's the last page. We're going to do the first two only. Now, let me say this about inequalities. You can graph them. In fact, you'll have problems where all you do is look at a graph and tell me the answer based on looking at the graph. That's fine. I need to show you a different method right now because I know what you're going to see later on in this course. And if I teach it this way right now, it's going to make what happens later easy. If I don't, we're going to have to learn a whole other method. So I'm just trying to make it where it's one approach. Are y'all follow that? Mm-hmm. All right, so as I'm doing this, you're going to be like, well, can I just do this? Most likely, yes. But, like, again, I know it's coming. All right, so here's what I want you to do. Take x squared minus 4x. Minus 12, what is it, less than or equal to? All right, less than or equal to 0. Okay, so you can graph it, which you guys did on that last problem with the calculators problem. But we're not going to do it this way. I want to show you a way without graphing it. So we're going to take this part, we're going to factor. What does that factor as? X minus 6 and x plus 2. All right. Now, here's what we're going to do next. Make yourself a number line right over here. All right, and now I'm not very, do it this way. I haven't been that way as a teacher for you guys, but this is one of those times where I do want you to be pretty in line with how I'm doing this exactly. All right, what two values would make this equal to 0? Negative 2 and 6. All right, so those are our critical numbers. Negative 2 over here and 6. Those are the two numbers that you're going to write in the number line. Just those two. Negative 2 and 6. Nothing else matters on that. All right, so here's what you do next. Up here, I want you to write the two quantities that we were dealing with, which what I mean by that is the x minus 6 and the x plus 2. And notice I left some space between those two quantities in the number line. That's intentional. All right. So what we're going to do is we're going to take numbers in those intervals and plug them into our quantities individually and determine if they are positive or negative. So what's the number less than negative 2? So we'll play negative 3. Negative 3 minus 6 is negative 9. So since that's negative, we'll put a negative right there. That represents just in that interval less than negative 2. So a number between negative 2 and 6, 0. What's it? 0 minus 6. It's another negative answer. So put a little negative. What's a number bigger than 6? 7, right? 7 minus 6 would be 1. It's a positive, so I'm going to put a plus. So that first row is just with the quantity x minus 6. We're going to repeat that process with the x plus 2. What's the number less than? Negative 3. Negative 3 plus 2. It's a negative. If we plug 0 in, we get a positive. 0 plus 2 is 2. And then same thing once we get to that 7. 7 plus 2 is 9. Another positive quantity. Whatever equals 0 is your critical numbers. Now, over here, this is where you need to pay attention and be careful. Here's our symbol that we're basing everything off of. Less than or equal to. Right? Now, what operations occur between the x minus 6 and the x plus 2? Add, multiplication, what is it? Multiplication. If you multiply two negatives, we get a positive. We multiply negative and positive, negative, and then of course two positives gives us a positive. We're looking for the one that is less than or equal to 0. Where's that happening? Between negative 2 and 6, and since it's equal to, inclusive, so we're going to have closed circles right here to include the negative 2 and 6. Everything in there is our answer. So what we would write in interval notation then is a bracket, negative 2 to 6. That'd be our solutions. All those values would satisfy this inequality. How do you feel about that? Okay, if you graphed it, you would just look, you would graph your parabola and figure out everything that's below the x-axis, okay, which you've done over and over again. Okay, I'm going to stay away from that today. I'll come back to it maybe next class. I want you to practice this approach because once again, know what you're going to see later on. This makes things a lot easier. Trust me. All right? You and your partner do example 2. Take out this part.
Do we need to graph them on the right side or
Nah, you don't have to. You don't have to. All right, so just solve that inequality. And then we'll check together. All right, hey, our last one. -2 to 5 halves. Non-inclusive, right? Because it's just strictly less than. Not less than or equal to. Now, the only thing that didn't happen on either one of these is both of them end up being like less than, right? What if this had been a greater than symbol instead?
That would be the outside.
It'd be these outsides, negative infinity to -2, union, 5 halves to infinity. You follow that? Question, yes.
Sorry, what if like the whole left side like was negative, so it was like negative, negative, positive in the red? Okay.
So like, if this was negative as well, negative infinity to 5 halves, but -2 would be a 0.
So it would be
So
negative
that would be-
infinity to non-inclusive.
There you go. That would be negative infinity to -2, not inclusive, like I said, union, -2 to 5 halves, which will happen later on down the road. Okay, not with these necessarily, because these are quadratics, they're gonna follow a pattern, but they will later on. All right, so 3 and 4, leave those. Probably not gonna do that example 4, to be honest. We're gonna treat 3 as our warm-up next class. Your assignment is on my math lab.
Yeah.
All right? The bonus assignment, I don't want to squeeze that in right now. I'll talk about that next class. There is a bonus assignment for this unit. We'll discuss that. All right?
Oh, I need to boost my grade.
You guys have a great one.